All right, let's jump right into this explainer. Today, we're getting hands-on with the JET's 15 MBD vacuumator. If you're studying marine and sanitary engineering, you know that understanding this exact piece of equipment is absolutely vital. We're going to take all those complex schematics and manufacturer data and translate them into clear, actionable knowledge. By the end of this, you'll be fully prepped to operate, maintain, and troubleshoot this system out in the field. Here is our roadmap for today. We'll be looking at technical specs, principles of operation, core components, routine maintenance, and finally, a troubleshooting guide. Starting off with Section 1, Technical Specs, the muscle behind the machine. Let's kick things off with a pretty impressive number, 2,880. When you're running on a standard 50 Hz grid, this unit is pushing a massive 2,880 rotations per minute. And that insane rotational speed is driven by a really efficient 2.2 kilowatt motor. This right here is the heartbeat of the vacuumator. It's what gives it the sheer mechanical force to pull a continuous vacuum while processing waste at the exact same time. Now, since you're going to be dealing with totally different electrical grids depending on where you are in the world, you absolutely need to know how this machine scales. Look at what happens when you plug into a 60 Hz grid. Your performance jumps to 3,480 RPM and a higher 2.55 kilowatts of power. Also, take a close look at the current consumption, because it's a fantastic practical reminder of basic electrical principles. Running this thing on 220 volts draws over 8 amps, right? But if you jump to a 380 volt connection, you're cutting that current consumption nearly in half. Moving right along to Section 2, Principles of Operation, the life cycle of a drop. So check out how this actually flows. Notice the direct, really streamlined path here. Air, sewage, and water are pulled from that suction inlet at the very top, and they're forced straight into the built-on macerator. That's where the waste gets actively chopped up. From there, it's pulled directly into the pump housing. It's honestly brilliant because it consolidates multiple waste treatment steps into one compact, continuous mechanical action before it discharges the return water. The real secret sauce here, the thing you have to understand, is that the vacuumator is fundamentally a liquid ring screw pump. What does that actually mean? Well, picture a helical rotor spinning inside a cylindrical housing. As it spins, a literal ring of liquid forms around it, creating these progressive crescent-shaped cavities. The depth of that liquid ring literally governs how the entire pressure system operates, touching the rotor hub on one side and the rotor tips on the other. This super clever design is what physically transports the macerated material from the suction side all the way over to the pressure side. All right, Section 3, Core Components. Inside the vacuumator. What's really cool to see here is the big macro picture right next to the tiny micro details. On one side, you've got the whole pressure chamber layout. You can see the layers, the pressure chamber itself, the O-rings, the end plate, and those big stables holding the whole thing together. But then on the other side, we zoom in on where the magic happens, the macerator. You can clearly see the rotating knife assembly that fixes to the shaft and how it works in total sync with the stationary knife to grind down the sewage before it even has a chance to enter the pump body. And we definitely can't ignore the motor that's driving this whole shebang. The manual actually specifies this is a highly specialized MEZ 7A90L-02 unit. It's a nearly 20 kilogram beast. Well, 19.6 kilograms to be exact. It features special flange mounting, an aluminum housing, a fiberglass plastic ventilator, and, this is key, an IP55 enclosure rating. That gives it serious protection against dust and water jets. When you're in a damp, totally unpredictable marine environment, that specialized enclosure is exactly what keeps this beast running smoothly. Which brings us to Section 4, Routine Maintenance, keeping the system flowing. Listen, when it comes to preventative maintenance on these units, discipline isn't just nice to have, it's mandatory. Your schedule scales pretty tightly by time. Daily, you've got to clean those connection pipes for the pressure switches. Monthly, you're hunting for air leakages. Yearly, you absolutely must check for and remove any scale layer. And definitely mark your calendar for this one. Every 2 years, or 6,000 working hours, you are scheduled for a major overhaul to completely replace the crucial shaft seals and electric motor bearings. We hammer these timelines home because we're not just telling you to check for scale layers for the fun of it, right? Ignoring this protocol has severe, expensive consequences. If you fail to replace those shaft seals at the 6,000-hour mark, you are practically guaranteeing water leakage directly into the motor. So instead of a routine afternoon replacing a worn seal, you're suddenly dealing with an entirely destroyed, flooded 20-kilogram machine, and trust me, a very messy situation on board. So, when you finally hit that 6,000-hour mark and it's time for the big overhaul, safety and precision are literally priority number one. Step one, obviously, switch off the electricity. Step two, unscrew the plug and completely empty the pump of liquid. Step three is vital for when you have to put it back together. Mark all the parts to ensure they go back in their exact correct angle and position. And finally, step four, dismount the pump in an upright position. Once everything is safe and upright, you've got a very strict sequence to follow. You're going to work your way inward from the suction side. First, remove the 4 screws to take off the suction chamber. You might need a rubber mallet to gently tap it loose. Then, unscrew the center screw to remove the macerator. Next, pull out those long stables. Only after that can you safely remove the end plate, the rotor housing, and finally extract the rotor itself. Oh, and a pro tip, straight from the manual, always use new O-rings and use a little soap water when you're seating those new shaft seals. It makes a huge difference. All right, Section 5, Troubleshooting Guide, Field-Ready Fixes. Look, even with perfect maintenance, things happen in the field. If you notice your vacuum gauge is steadily dropping, your absolute first move should be consulting the piping diagram to hunt down air leakages. If the system control is spotty or it's failing to engage at the right fluid levels, jump right in and inspect and clean your level and pressure switches. Readjusting those switches is a standard monthly maintenance task for a very good reason. They are almost always the culprit when things get weird. You're going to spend a lot of your troubleshooting time staring at the control cabinet, so you need to know these modes inside and out. Auto is your normal operation. It relies entirely on those pressure switches we just talked about cleaning. Run actually bypasses those switches, forcing the pump to run independently. This is awesome for isolating a mechanical issue from a sensor issue. And don't forget the alarm function. Cabinets should be preset to trigger an alert if the pump runs continuously for 10 minutes. If that goes off, it's signaling a total failure to build a vacuum. Well, we've covered a massive amount of ground today, from the sheer technical muscle of that MEZ motor to the fluid dynamics of the liquid ring, all the way down to the meticulous step-by-step sequence for replacing those macerator knives. At the end of the day, a machine is truly only as reliable as the technician who maintains it. So the next time you're on a vessel, miles out in the middle of the ocean, think about all that precision engineering working silently beneath the deck. The real question is, are you ready to take command of it and keep the system flowing? Keep reviewing these schematics, stay sharp, and we'll see you in the next